Hello everyone, so today we will be looking at Form 4 Chapter 4, the periodic table of elements. So in this chapter, we will be looking at how the periodic table of elements is constructed, how the elements in the periodic table are arranged, and also the properties of the elements that can be found in the periodic table. So before we actually go into the details of, what we're going to learn in this chapter, let's have a short little recap of what we have learned in Form 4 Chapter 2. So what we have learned in Form 4 Chapter 2 is the standard representation of an atom. Right, we've learned the standard representation of an atom, and basically how we would draw the standard representation of an atom is first we would start out with the symbol of an element, right? The symbol of an element. And we usually denote the symbol of an element as X if we are not referring to any specific element. Then we will go on to write the nucleon number. So the nucleon number is positioned on the upper left corner of the symbol of the element, and it is denoted by A, right? The nucleon number is written on the upper left of the element and is denoted by A. And then we have the proton number of the element, which is denoted by Z and is placed on the lower left corner of the symbol of the element and is denoted by Z. So this is how you would draw the standard representation of an atom. You have the symbol of the element, and then you have the nucleon number, and also the atomic number or the proton number, right? So for example, let's say we have sodium. So sodium has 11 protons and 12 neutrons. So if I asked you to draw the standard representation of sodium, what you have to do is first you have to start out with the symbol of the element, which is Na. And then you have to write the nucleon number on the upper left. So do we have the nucleon number? No, we do not have the nucleon number. The nucleon number is equivalent to the sum of the proton number plus the neutron number. So in this case, proton number and also the neutron number is given. So proton number is 11 and then the neutron number is 12. So you have the nucleon number is equal to 23. So if we want to draw the standard representation of sodium, first we have to have the symbol. So we have already put the symbol here, Na, and then we have to go on with the nucleon number, which is on the upper left. And then you go on to write the proton number on the lower left. So this is how you would draw the standard representation of sodium, right? However, in certain occasions, you would not follow the standard representation, and for example, in the periodic tables, different periodic tables may place the proton number and nucleon number in different areas. For example, it could write Na 2311 or Na 1123, right? So how would you be able to tell which is the proton number and which is the nucleon number? Well, just figure out which number is bigger. So the bigger number would be the nucleon number, and the smaller number would be the proton number or atomic number. And so besides the nucleon number is actually also referred to as the relative atomic mass, and this is because in an atom you have protons, neutrons and electrons, right? However, the mass of the proton and neutron makes up most of the mass of the atom, which is why we can assume that the nucleon number is also equivalent to the relative atomic mass of the element, because the mass of proton and neutron added up together is basically the same as the relative atomic mass, and this is because the electrons have a very negligible mass. The mass is so insignificant that we only take into consideration the mass of the proton and neutron in the atom, and each proton and each neutron has a mass of 1 unit, so the nuclear number is equal to the relative atomic mass. While another name for the proton number, you can also write it as the atomic number. So that is for a short recap session of what we have learned in Form 4 Chapter 2, and it relates to what we're going to learn in Form 4 Chapter 4. So now let's look at the periodic table of elements once again, right? So you will notice that the periodic table of elements is a table, right? And in this table, how you would read this table is from the left to the right. Left to right. So if you want to read the periodic table, you would start with hydrogen. And then you would go to helium, lithium, beryllium, boron, carbon, and so on. So you go from the left to the right, and then you go down one row, and then you continue from the left to the right, go down a row, from the left to the right, and so on. So what you will notice is that, right, so if you look at hydrogen, it has 1 proton number, helium has 2 protons, lithium has 3 protons, beryllium has 4 protons, and boron has 5 protons, and so on. So what you will realize is that this periodic table of elements is actually arranged in ascending order of proton number, right? You have hydrogen with 1 proton, and then you go to helium with 2 protons, and so on. So let's write that down. Arranged in ascending order of proton number, right? And in this periodic table of elements, you also notice that there are vertical columns and also horizontal rows. So what do these vertical columns and horizontal rows actually indicate, right? What do they mean? Well, if you realize, if you look at this periodic table, you will notice that there are actually numbers assigned to each of the vertical columns, and there are also numbers assigned to each horizontal rows, right? So actually, each of these vertical columns are called groups. So the first vertical column would be group 1, the second vertical column would be group 2, and so on, right? This third one would be group 3. And if you look at the horizontal rows, the first horizontal row would be period 1, the second would be period 2, and the third would be period 3. So basically, the vertical column is called group, and the horizontal row is called period. All right, let's write that down. The periodic table is divided into 2, which is the vertical columns and the horizontal rows. So these vertical columns are called groups, and the horizontal rows are called period. So what are these groups and what are these periods, right? What are these groups and periods? So if you notice, right, let's say we take sodium as an example, right? Let's take sodium as an example. So sodium has 11 protons, which means it also has 11 electrons. So the electron arrangement for sodium would be 2, 8, 1. And if we look at the periodic table, right, we will see that sodium is actually located in group 1 and period 3. So what do you notice from the electron arrangement? You will notice that the last number, which is the valence electron, the valence electron for sodium is 1, right? The valence electron is 1. And there are 3 shells. 3 shells occupied by electrons. And coincidentally, the period is 3 and the group is 1. So what does this mean? Well, it means that the groups are determined by the valence electron, while the period is determined by the number of shells occupied by electrons, right? Yeah. However, right? However, the group is not always the same as the number of valence electrons. Of course, for sodium, yes, it is true that it has one valence electron, and coincidentally, the group is also group 1. However, that is not always the case. So these groups, there are actually two cases of how you would determine the group of the element. So if the valence electron is equal to 1 or 2, then the group would be equal to the number of valence electron. However, if the valence electron is 3, 4, all the way up until 8, the group is not equal to the number of valence electron. So for these elements that have more than 2 valence electron, the group is actually equal to the number of valence electron added with 10. Added with 10, that's right. So for example, let's say we have oxygen, right? Let's say we have oxygen. So oxygen has 8 protons, which means it also has 8 electrons. So the electron arrangement for oxygen would be 2, 6, right? So if we actually followed what we did earlier, we would know that it has 6 valence electron, right? 6 valence electron. So it should be group 6, right? But it's not. It is not, because the valence electron is more than 2, right? It's more than 2. More than 2, right? This is more than 2 valence electron. So oxygen, the group is actually equal to 6 plus 10, which is 16. So oxygen is in group 16, and it has 2 shells occupied by electrons, 2 shells, so it is period 2. So if we look at the period table of elements, right, oxygen is indeed in group 16 and period 2. It is not in group 6, right? It's not in group 6. And for your information, right, over here, right, the elements that can be found from group 3 to group 12, they are actually known as transition elements, and we will learn more about them later on. So now that we already know how the elements in the period table are arranged and how the period table is constructed, let's look at a few examples in order for us to understand better on how we could answer these questions if they come out in our exams, right? So let's say we have beryllium. So given that for beryllium, the nucleon number is 9 and the proton number is 4, right? As given here. So we know that beryllium has 4 electrons because it has 4 protons. So the electron arrangement will be 2, 2, right? So it will be in group 2, right? Because the valence electron is 2, is not more than 2, it is 2. So for elements with valence electron of 1 or 2, we don't have to add 10. And then it has 2 shells occupied by electrons, so the period is 2. Very simple. Next, let's look at carbon. Now, carbon has 6 protons, which means it has 6 electrons. And the electron arrangement is 2, 4. And since the valence electron is more than 2, right? 4 is more than 2. So we have to add 10. So the group is 14. And the period is 2 because it has 2 shells occupied. Right? It has 2 shells occupied by electrons. Next, let's look at aluminium. Aluminium has 13 electrons, which means it's going to be 2.8.3. So 3 is more than 2. So we have to add 10. So it is group 13 and period 3 because it has 3 shells occupied by electrons, right? So if these questions come out in your examination, you should be able to answer them. Next, before we go deeper into what we're actually going to learn about this chapter, let's look at the history of the periodic table. So in the history of periodic table, we learn about six scientists which have proposed their own way of constructing the periodic table. So firstly, we have Lavoisier, or however you would pronounce his name. So according to Lavoisier, he actually arranged the periodic table. He constructed the periodic table by arranging the elements according to gases, non-metals, metals, and metal oxides. So this is the first person who proposed a way to construct the periodic table. Secondly, we have Dobrenier. So Dobrenier proposed to construct the periodic table in groups which consist of 3 elements, which is called a triad. Next, you have Newlands. So Newlands proposed the law of octaves. He introduced the law of octaves, in which he arranged the elements according to their atomic mass. Then came the 3 M's. Fourth, there was Mayer. So Mayer, he plotted a graph of atomic volume versus atomic mass. And then came another M, which is Mendeleev. So Mendeleev, he proposed the periodic table to be constructed according to the atomic mass. And at the same time, he arranged the elements with similar chemical properties in a group. Right. And then lastly, we have Moseley. So Moseley, he arranged the elements in the periodic table according to the proton number. So this right here, according to the proton number, is the latest and current way of constructing the periodic table, right? The current or latest way, right? Because just now we already looked at the periodic table, and yes, right, it is arranged according to the proton number from the left to the right, and then you go down a row and then you go from the left to the right again. Next, we're gonna have a brief overview of what we're actually going to learn in this chapter before we go into the details of this chapter. So what we're gonna learn about is the elements in the periodic table, right? We're going to learn about the elements in the periodic table. So what are we going to learn about, right? What is it so important that we have to learn about these elements? So we're going to learn about the properties, right? So what type of properties? We're going to learn about the physical properties, and we're also going to learn about the chemical properties. So in terms of the physical properties, right, what are physical properties? So physical properties are actually observable properties, right? They can be seen with the naked eye. Well, chemical properties, right? Chemical properties involve reactions of these elements, right? Reactions of these elements with other substances or other elements, other molecules, and so on. So let's look at the physical properties first. So what are we going to talk about in the physical properties? So we're going to talk about the appearance of the elements, right? We're going to talk about the appearance of the elements, and then we're going to talk about the conductivity of the elements. And conductivity is again divided into two, which is the conductivity of heat and also electricity. And in general, right, in general, metals, right, metals are good conductors, and non-metals are bad conductors. This is in general, right? In general, metals are good conductors of heat and electricity, while non-metals are bad conductors of heat and electricity. And then we're going to talk about the density, right? And for density, right, usually metals have a high density, while non-metals have a low density in general, right? And then we're going to talk about solubility. So for solubility, we will only briefly talk about solubility, which is whether it's soluble in water or not soluble in water. Then we're going to talk about the hardness for solids, right? Hardness for solids. So is the solid hard or is it soft? Can it be cut with a knife, or do you require other equipment in order to cut that metal? In order to cut that solid, right? And then lastly, we're going to learn about melting and boiling points. So this is one of the most important parts of physical properties. And the melting and boiling point of the elements are actually dependent on the forces of attraction. The forces of attraction that keeps these elements together, right? So we have two types of forces of attraction, which is for non-metals and for metals. So in general, for non-metals, right, they are held together by weak van der Waals forces of attraction. And metals are held together by strong metallic bonds. Strong metallic bonds. For the weak van der Waals forces of attraction, when the size of the element increases or the size of the atom increases, the force of attraction will actually increase. So when the force of attraction increases, then you require more heat to overcome the forces of attraction, therefore the melting and boiling point will increase. Meanwhile, for metals, they are held together by strong metallic bonds. And when the size of the atom increases or the size of the element increases, then the force of attraction will actually decrease. So you can think of this as the opposite, right? Van der Waals force of attraction are actually weak. However, when the size increases, the force of attraction will increase. The metals, they are held by strong metallic bonds, but when the size increases, then the force of attraction will actually decrease. And in general, non-metals have low melting and boiling points, while metals have high melting and boiling points. All right. Next, let's look at the chemical properties, right? The chemical properties. So when we talk about chemical properties, what we're actually going to learn about is the reactions of these elements with other substances. And we're also going to talk about the reactivity of these elements and how the reactivity differs when we are going down the group. Right? How does the reactivity differ when they are going down the group? And this reactivity down the group is actually dependent on the electron arrangement. As in, is the electron arrangement stable, right? So stable could be, duplet or octet. Or is it unstable? So if the electron arrangement is stable, then it is not reactive. But if the electron arrangement is unstable, then it is reactive. And the reactivity down the group is actually dependent on two factors, which is electropositivity and electronegativity. So if we break down the words, right, electropositivity, Electro, we will actually refer to electron's positivity because it will become a positive ion. Electronegativity, negative referring to negative ion, electro meaning electron. So what is electropositivity and electronegativity? Electropositivity is actually the tendency to donate electron to donate valence electron to become a cation, which is a positive ion, right? While electronegativity is the tendency of the atom to accept electron to become an anion, which is a negative ion, right? And the way to remember which is whether cation is positive or negative, just look at the T over there, right? The T looks like a positive, so cation is positive. Anion, it has an N, which stands for negative. That's how I would remember which is positive and which is negative. So it is dependent on electropositivity and electronegativity, and we will look on how the electropositivity and electronegativity changes when we are going down the group. And of course, when we talk about the group, we're actually talking about the group in the period table, which is the vertical columns, right? So in summary, what we have learned in this video is we have learned about the periodic table of elements. First, we have looked at how the periodic table of elements is arranged, right? So the elements in the periodic table are arranged according to the proton number, right? Proton number from the left to the right, and then we go down, and then we go left and right, and so on. And then we have looked at how the periodic table consists of vertical columns called groups, and also horizontal rows, which are called period. And the group of the periodic table is determined by the valence electrons. However, if the valence electron is more than 2, then we have to add 10 to determine the group. And then the period of the period is determined by the number of shells occupied by electrons, right? That is what we have learned. And we have also learned on the history of the periodic table, which is what the 6 scientists proposed in the construction of the periodic table. We have also gone through some examples on how to determine the group and period of the elements, and we have also gone through the overview of what we're actually going to learn in this chapter, right? We have learned that we're going to learn about the elements in the periodic table, and specifically we're going to learn about the physical properties and also the chemical properties. For physical properties, we're going to learn about the appearance, conductivity in terms of heat and electricity, density, solubility, hardness, and also the melting and boiling points. And in general, conductivity, metals are good conductors, non-metals are bad conductors, meaning they are good insulators. And for density, metals usually have high density, non-metals have low density. And for melting and boiling point, in general, non-metals have low melting and boiling points, while metals have high melting and boiling point. And non-metals are held together by weak van der Waals forces of attraction, while metals are held together by strong metallic bonds. And these weak van der Waals forces of attraction, when the size of the elements increase, the forces of attraction will also increase, therefore the melting and boiling point will increase. For metals, they are held together by strong metallic bonds, and when the size of these metals increase, the force of attraction will decrease, therefore the melting and boiling point will decrease as well. And then we learned that the chemical properties of the elements is determined by the reactivity of the elements with other substances, and this reactivity differs down the group, and this is due to the difference in reactivity is dependent on electron arrangement. So if it is stable, it is not reactive, and if it is unstable, then it is reactive. And the reactivity down the group differs due to electropositivity and electronegativity. Electropositivity is the tendency to donate or release electrons in order to become stable and become a cation, while electronegativity is the tendency to accept electrons to achieve stable electron arrangement and become an anion. So this has been Form 4, Chapter 4, Chemistry, the periodic table of elements, Part 1, Introduction. Thank you very much. I hope all of you have all of you are able to understand everything that has been taught in this video. Thank you and bye bye.